Okay, so now let me go back. Okay, are you still seeing the PowerPoint?
Yep.
All right. So infinities and indivisibles transcend our finite understanding. The former, infinity, those are the large kind of infinity on account of their magnitude. The latter, the indivisibles, the tiny infinities, because of their smallness. Imagine what they are when combined. Of course, that was Galileo. So that's kind of the idea behind the two infinities: infinite largeness, infinite tininess. You guys remember at all algebra, high school days? Sometimes a line would approach, a graph would approach a line but never quite get there. They even had a crazy name for that line it was approaching, called an asymptote. Anyway, that's this kind of small infinity. You can keep getting closer to something mathematically without ever getting there. For example, let's say we're at a distance of 1. Okay, then let's say we get to half the distance. Now we're at 1/2. What's half of a half? 1/4. And then half of that is an 8. And half of that is a 16. Half of that is a 32nd. When will we ever get to nothing? We won't, if you keep following that plan. I mean, you'll be so close. It'll be incredible. But
it's always like 1 over it. So
yes.
1 over 64.
Right. It's just smaller and smaller fractions. Correct. Always 1 over. So that's what I mean by this indivisibles, the tiny infinity. Okay. A couple passages to consider. I'll tell you what, I'm going to put them up and just let you take a glance at them, maybe for notes. By the way, I should tell everybody, I'm not going to ask you for details on this. What I'd like for you to, this is kind of like a video essay. And I wanted to see if you catch my main point. Okay? Now you still might be interested as we get going here to put a couple of things down, because I'm sure some of this stuff is going to surprise you. But so just general notes. Don't worry. Don't try to get this all down. Now maybe you want to put down the reference like Job 11, Job 22. I'll just read the bottom one. As the heavens are higher than the earth, so are my ways higher than your ways, and my thoughts than your thoughts. Okay, so let's get a little introduction here. The idea of number, the Bible tells us that he's even got a count on the number of hairs, and he knows that when I do this, he's got the new count. And he's just always got that stuff down. This is one of the slides we're going to look at in a little while. It's one portion of the trip we're going to take, and it's really dense with star and other planets and objects like that. And I thought hang on. I guess what did I miss? Oh yeah, I missed clicking that. Just throw this passage out there from Psalm 147. He determines the number of the stars. He knows exactly how many there are. And check this out. He calls them each by name. And some of those he's actually shared in the Bible. We're going to look at a few of them today. But I love the ending part, fitting infinity. Great is our Lord and mighty in power. His understanding has no limit. Okay, now this is crazy, but this is just to get you in the feel of things here. This is similar to what we were just talking about. Let's say we were going to go on a field trip tonight. We're not, but if we were, let's say I have this nice luxury coach waiting for us out there. Maybe with this size. Okay, we've got a supersized limo. There we go, stretch limo. And a Hummer, thank you. We've got all the requests in now. Anyway, and we're going to go to the Sears Tower. Okay, but we have a crazy rule for our field trip. And the crazy rule is each day we're allowed to go half the remaining distance. So, what is it, pretty close to 80 miles from here to the Sears Tower. So on day one, we can go 40. So I've got it all arranged for us to stay in a motel. We're going to have pizza. We're going to have a good time. We'll do some math so that we really have fun. I heard some expressions of pain here. Anyway, and then we get up the next day. We've got 40 left. We're only allowed to go 20. Next day we get up, we got 20 to go. So this is the same kind of concept. You can only go 10. I mean, after several weeks, God forbid, let's say we're camped out on the sidewalk in front of the Sears Tower because we couldn't go the remaining. So not the greatest place to camp. So we get up the next day, we got 10 feet left, we can only go 5. So will we make it to the Sears Tower? If you follow the rule, I mean, when there's 1 inch, you can only go a half. When there's a half, you can only go a quarter. I mean, if you follow the rule, we'll never get there. It's this idea in math that you can keep making something smaller and smaller and yet never have it hit 0. Is that small infinity again. Another look at infinity. I don't know if you've ever, I'm sure you have, looked in the bathroom mirror and held maybe a handheld mirror behind, and you get this kind of left side of the screen effect. And on the right side, I've got a video running there that kind of turns in on itself. These are all little views of kind of what infinity is like. Okay, and then just a little bit of math. We divide 4 by 1, we get 4. Now what I'm going to do is cut the denominator in half each time. So this time, let's divide 4 by 1/2. Half of what is 4? 8, right? And if we cut it in half again down to a quarter, now the answer is going to double again. So if you keep making the denominator smaller, the answer is going to get bigger. And if you do it again, now you're up to 32. And anyway, it's going to keep getting bigger and bigger. And what's going to happen here, I know you don't maybe get that notation, but what it's saying is, as the denominator gets smaller and smaller, the answer is getting bigger and bigger, and in fact approaches infinity. But you can't divide by 0, right? You get why you can't divide by 0 because, well, here, let me go to the next slide where it talks about that. This is garbage because for it to work, you'd have to take your answer and multiply it by 0 and come up with the answer of 4. And you're just not going to find anything times 0 that will ever equal 4. I don't care. There's nothing. So we call that undefined. If we do it, even this is ridiculous because there's what? A trillion answers. What times 0 equals 0? Any number. Okay, so that's still messed up and very unclear, undefined. Now this is legit. We could ask ourselves, what number times 4 equals 0? And now there is only one answer. It is 0. So whenever we get a little sloppy and accidentally put 0 in the denominator, we're headed for trouble. We can't handle it because really infinity is involved. Sorry, supposed to bypass that. So this is my presentation. Actually, this is my series. I have a series of 7 of these. And if you want to actually get an idea of what all 7 look like, I'm only going to be showing you 3 of them. You can go to that website, divinemath.com. And you might want to play around with that, but you don't have to. That's strictly optional. Okay, so now back to our main presentation, the 2 infinities. So we've got a little bit of a introduction, got warmed up a little bit. So at the center of our presentation, this is kind of weird. We've got a guy who's sleeping, he's taking a nap on a blanket in a park in the downtown Chicago area, right by Lake Michigan. You can see he's got some things available with him, a book. He looks like he's got food, I don't know, all kinds of things. Okay. Now, the idea here is the camera, when this was being taken, was 1 meter away from him. So that's about doorknob height, approximately 1 meter. So that's the image you're seeing. What we're going to do then in the next picture, as we move out, is we're going to go 10 times the distance. So the next picture, we're going to be at 10 meters. And we're going to be at 100 meters, all this times 10. And then 1,000 meters. And then we're going to just keep going like that. And then later we're going to come back to the 1 meter, and then we're going to go down by a factor of 10. We'll be at 1/10 of a meter. And we'll only see his hand. And then 1/100th of a meter. And we might even get closer to some of Michelle's, the things Michelle sees in the OR. So we're going to look at some, we'll look at a few things. Okay, so that's kind of the idea. Now I've got several tours here. We're going to take the one with the guy in the blanket first. And just to explain the markings here in the top right, that keeps track of the distance. I don't know if you remember that, but any number to the 0 power is 1. And because that exponent's going to change each time, we use that format. But that's 1 meter away. Okay? And then there's all these little things you can do. You can click on the tape measure to find out, you know, like here, I'll just do it. It'll give you real life common objects that are about that size. Okay, and then down here, it's time in seconds. Anyway, it gets kind of interesting as you go way out and way in. Okay, so we're going to start going out. So first step, you see now we're at 10 meters. And now you can see the grass around our friend. Surprised there's that much of it, and it looks pretty healthy. We go out the second step, we're now at 100 meters. And now you can see Lake Drive off to the left. You can see some of the boats that are docked. And by the way, the square that's around in the inner portion of it, that is indicating where we were in the last picture. Okay, and when we go in, that'll be more helpful because that'll be where we're going. Got it? So right now it's like a trail. 3 steps out. Now we're at 1,000 meters. And you can see some pretty, common objects. That's Soldier Field down there in the left corner. Up on the top there, that rounded section, that's the planetarium in Chicago. And off to the right there, down in the lower right corner, that used to be an airport right on the lake, Meigs Field. It's now been closed, but anyway, so all right, we're out 1,000 meters. 10 to the 4th power, now we're up 10,000 meters. You can see a pretty good share of Lake Michigan and a pretty big chunk of the city of Chicago. 5, if we go up to the next one, we're going to be at 100,000 meters. And now we can see, I mean, this is down here on the bottom toward the right, that's Indiana. Can't quite see to Wisconsin yet, but you also can see kind of not sure. There's different coloring of the water right near the shore. You know, that's got all kinds of implications because Gary, Indiana is very close to being in this picture. And Gary was big time steel mills and unfortunately known for pollution problems. Okay, 6 steps up. And now you can see all of Lake Michigan. And you can see the Chicago and suburbs going in, kind of a megalopolis there. You know, it's interesting. I'm big into technology, but I raise this question. How impressive are man's accomplishments from this height? It's ironic, but the only thing you can really see here is some of the damage we've done. I can't see the Sears Tower. All I can see is a lot of lights at night. Maybe we've messed up Lake Michigan a little bit. Okay, on we go. 7 steps out. And when you go out 7 steps, you just about can see the whole Earth. It's really close. And you can see all the storms. You can even see hurricane formations. See that one over here on the right? By the way, there's a pretty constant number of storms every day on the Earth. 8 steps out, and now we're starting to see some of the objects around us in space. Again, that square is where we just were. You can see we didn't quite have the whole Earth in the picture. 9 steps out, and now we're out to 1,000,000 kilometers. No, that arc is not in the picture. I mean, that was added afterwards. That arc is showing the orbit of the moon. How, you know, the Earth is still in the center of the square, and that's the path that the moon takes as it orbits the Earth. 10 steps out, and what we're starting to see now, you still see the moon orbit in there. What we're starting to see now, the green path is the Earth's path as it goes around the sun. And as we go out, and again, you'll see some other planets start appearing. Again, we're the green one, but there's others, Mars, Venus. Yeah, these are the inner 4 planets here in the inside. 13 steps out. And I think the only thing we don't have on here is Pluto yet. By the way, did you see the recent pictures of Pluto? Well, yeah, it's on and off. And lately, anyway, did you see the pictures? Yeah. Okay, 14 steps out, 15 steps out. And now, let's see, is there anything I want? Yeah, that now, because all the planets orbit the sun, of course, the center of everything we're in here, from here on out, is the sun. I forgot that, you're probably wondering what the hand is. When you have big numbers, that's a count. And so we're up to what? 1 quadrillion meters is how far away from Earth we are now, from that guy on a blanket. And 1 quadrillion is about how many bacteria are in each of our bodies. Just to make some kind of a comparison on the count of something. No, I didn't actually count them. And if you want to know what a quadrillion second is, it's 32 million years. So we're really getting up there. Of course, we're multiplying by 10 each time. Okay, 16 steps out. Doesn't look much different. 17. And at 18, I've got a highlight to point out to you. It's right down there in the bottom right corner. That's Arcturus. And Arcturus is one of those that the Bible mentions in it. It's one of those many that God has named. Job 38, where he brings up Mazzaroth and Arcturus. And this is Arcturus. Okay, so now we go on. 19 steps out. I know you're probably wondering, how far am I going to go? Right? 19, thanks to Hubble, we're going to go pretty far. 19 steps out. Now, do you notice how like crowded it looks out here? It almost looks like a cloud of stars. These are, by the way, those are all heavenly objects. If we go out a couple more steps, you're going to see what's going on here. Yeah, here's 20, and then if I go out to 21, now you can see what we were looking at. We were looking at an X, and if you look real closely, you can see that guy in the blanket. No, not quite. But anyway, we're on one of those spiral arms of the Milky Way. That's our home galaxy. So now we're out 10 to the 21st meters out from where we took off. Okay, we're still going. 10 to the 22nd. Now you can see our galaxy is practically within the square. 10 to the 23rd. 10 to the 24th. There's kind of an interesting object to the left side of that square. That's a cluster. Each of those little dots is a galaxy. That's the Virgo cluster of galaxies. Yeah, and stuff is, I mean, just think of it. When God said, let there be, They were all there. 10 to the 25th. 1 billion light years. You know what a light year is? A light year is how far light travels in a year. It's pretty far because you know how fast light is? 186,000 miles each second. Travel out for a billion, go out a billion, do that a billion times, and that's how far out we are. And at the moment, this is the end. This is the high. By the way, when I first created this presentation, I had 2 left slides. Now, I'm not going to tell you how long I've been working on it. Well, I guess I can give you an idea. It must have been around the late 80s when I first put this together. But I've had to add to because mostly of Hubble. Now, this is a famous image called the Hubble Deep Field image. Everything you see there is a galaxy, and you're wondering, how did we get this picture in such good color? Well, it's kind of an interesting story because, I mean, they had to duke around too. I'm going to show you a video here. And Rhonda, are you still there?
Yep,
hey,
I'm
Ron,
still here. Yeah, I just had
okay, you are still there. That's okay. I probably put you to sleep.
No, it's fun.
This is where I don't know. When I open this next video, I'm thinking you're going to lose the image. So tell me, and then I'll stop it and I'll try to reshare the different screen. So anyway, here we go. You see anything, Rhonda?
I still see the slideshow.
Okay, I'm going to stop this and try to reshare.
Into a dark, unassuming.
See something different now, Rhonda?
Yes, now I see the Hubble Deep Field
Good.
MOV, that MOV.
Edge of sky to find young galaxies twinkling at the edge of the cosmos.
For the Hubble Deep Field, it was important that we get a essentially unblocked view of the distant universe. We want it to be unblocked by anything in our own galaxy, that is bright stars or dust in our galaxy. We wanted to avoid any bright nearby galaxies that might have essentially dominated the picture. And so we had to do some studies to find a field of sky that was essentially boring in every way so that we could look at the distant galaxies.
The team targeted Hubble's continuous viewing zone, narrow patches of sky near the north and south poles, where Hubble can stare for several days without being blocked by the Earth. The long exposure brings out wispy detail in galaxies as far as 12 billion light years away. But the telescope also captures light that astronomers need to filter out.
The problem is that the telescope itself is subject to radiation from charged particles, most of which come from the solar wind. And those also leave little spots of light on the detector. So when you see one of the Hubble images, it's covered with these spots, like the measles. You have to take a whole bunch of pictures. These spots will move around because they're not on the sky, but the galaxies and stars will stay there. So you take a whole bunch and you combine it together, keeping only the things that don't change from image to image.
In all, it took 350 images with 3 different color filters for the team to piece together the final Hubble Deep Field image.
Well, the thing that amazes me when I look at the Hubble Deep Field, first of all, is just how many galaxies there are. This tiny spot on the sky, and almost everything you see in the image is a galaxy. Each of those galaxies has anywhere from 1 billion to 100 billion stars in it. So we have before us in this image the history of the universe that we can figure out what it's going to tell us. And in many ways, it's like going out on a very dark night and staring up at the sky, and you realize how tiny a part of the sky it is, and yet you're seeing these vast systems of stars. What an amazing universe it is we're looking at.
Okay, Rhonda, I'm going to share a different. Well, Actually, just hang on a second. I think I'm going to hit the second video, and then I'll try to pause it and reshare.
Okay.
Okay, now I'm going to try resharing. This only happens in the beginning.
The best of Hubble.
What?
I see the best of Hubble.
Yeah, good. Okay. Now I missed stopping, so see if I. Now I missed it again. I wanted to draw your attention to the very bottom of the screen. I don't know if you can tell. Right in the words, there's this little square dot that's yellow. And it says, in an area of the sky roughly the size of this dot, Hubble found more than 1,500 galaxies, a concentration considered typical of the universe. Okay, a question for Rhonda. Are you getting only residual audio?
I'm getting the audio from the computer.
You are?
Yeah.
Oh, that's really good news. Okay, good. Okay, so now I gotta change my sharing options again. Let's see. So first of all, I gotta go back here, and then where's my Hangout? Right here. Okay, share. Okay, now we're pretty much going to stay in here. Sorry about that moving around, but I'm glad that that could be done. So now we're out to the limit. We're going to head back in. Okay, we're going to go back in much faster. So, fasten your seatbelts here. So 25, and remember, each time we're getting what? We're dividing the distance by 10. So you can see we just went from, now we're at 1 septillion, now we're down in the sextillions, so we're continually getting closer. Now there's our galaxy. So, you know, if the kids were along, the kids in the back seat are saying, oh, how close are we to home, Dad? Okay, so on we go. 21, 20, 19, 18, heading in. There's our solar system. Now we're really getting close to the neighborhood. And there we can see the sun at the center of the solar system. There's our Earth orbit and our home planet. This is where it would be really nice to have a good set of brakes, which, as you know, is half the problem when the astronauts go up there coming back, the heat shield. 6 steps back to there. 5, 4, 3, 2, 1. And now we're back to where we started. Now we're going to keep going. And now the little square in the middle is our next frame, so to speak. And you notice what happened there. In the, so we're real close to the hand. We're only 1/10 of a meter away. And notice the distance now is 10 to the minus 1. That means 1 over 10. So we're at 1/10 of a meter. Going in again at 10 to the minus 2, we can see some of the pores. Minus 3, we're going to head into a pore here. Okay, a single one. 4 steps in, we're at 1/10,000th of a meter now. And when you go in 5 steps, something really important is here. A white blood cell. And this is actually, again, thanks to science, this is actually a photograph. When you go in 6 steps, now we're getting close to the white blood cell. 7 steps, and you can actually see your DNA. That spiral that has all of our personal characteristics, hair color, height, you know, all kinds of things that make us up. If you go in 1 more step, now we're up real close to the DNA. 9 steps in, now we're even closer, and we're going to zero in on one of those little pieces of the DNA. And this is kind of interesting. 10 steps in. I actually don't have this slide in this place. This is actually what? They sometimes call it inner space. You know, out there is outer space, inner space, and it looks spookily like outer space. Of course, the rules are a little different than here. The rules out there are based on mostly gravity and forces of that type. In here, they're electronic forces, magnetism. But it's, again, it looks an awful lot like where we were before. 11 steps in, 12, and something has started to appear in the center here now. 13 steps in. Now let's get it a little bigger. We go in 14 steps. That's not the one I wanted yet. I want to do this one. That is a carbon atom. And the reason I know there's a carbon atom in this picture is because anything living has carbon. So when we went into that hand, and here you're looking at a carbon atom. And now I'm going to bring up this quote from Pythagoras. You know, and get rid of the carbon atom label. But Pythagoras said, everything is arranged according to number. And he's been mocked as being, you know, he was around BC. And it's like, oh yeah, the poor guy, they didn't know much back then. But you know, Pythagoras really had it right. I mean, what you're looking at are atoms, okay? You know what happens if you try to break those apart? It's called an atomic bomb. Okay, we have this big speed bang, everybody's gone. Okay, so really, you can't have a fraction of an atom, not if you want to exist. So really, every element that make us up have a counting number of atoms in it. Just the way God made the universe. 15 steps in, now this is about the limit, and 16, it doesn't look a whole lot different. We're just getting real up close now to the atom, and these are things like quarks. Some of these objects that they're studying. But, so, what we've done is taken a trip. I don't know, who can remember how many steps out we went? 26. And we went in 16, so how many steps altogether? 26 plus, 42 steps, 42 powers of 10. Well, that's it. I haven't checked this week, but basically this is now the limit of our scientific discovery. But as you know, we discovered new microscopes. We already have a replacement up there for, I shouldn't say a replacement, but they have what, the Kepler telescope is up there looking out. Still can't do what Hubble does. They're going to really miss Hubble when it's gone. That's pretty awesome device. Okay, so now that's pretty much the main tour I wanted to show you. I just want to show you a couple. I also have in the middle row a number tour. And I'm going to just go a little bit on that because I just want to show you a few features. We don't have time. I mean, there's so much to explore here. It would take a week. But so what I'm going to do is go back to this first slide, and then way on the bottom, I'm going to, whoops. Well, it's close. I'm going to click on this because then it's going to go to the number tour. So now the number on here is how many meters. And when there is an object that's about that length, again, meter, yardstick, I'm going to put the object up. Like in this case, a meter is just about what most sunflowers go to. So anyway, we're going to go up. And you may question these are my famous numbers. Okay, square root of 2 is a big deal because it's the diagonal of a square. And when they first discovered that, they thought, oh my gosh, this is an irrational number. It's not a nice whole number, the square root of 2. Anyway, another one we're going to look at. You're going to hear about this in my last presentation, a number that's all over in God's creation, called the divine proportion. Usually the Greek letter phi is used to represent it, but I'm just passing by right now. Okay, I don't know if you've ever looked on an electronic calculator, but there's a key called phi. Phi is really important in all kinds of things, including finances, because E is the perfect base for what? Compounding interest continuously. Anyway, that's a famous number. We're passing that up at about 2.7, and you guys, I'm sure, have all heard of pi. So let me just move on a little bit. Oh yeah, and here's one where I had a length again. 10 meters is, believe it or not, the length of the largest mammal on Earth, the U.S. And that's the reason I have it up there. 10 meters. That is a big creature. 11. I want to stop here and just talk a few minutes about 17. 17 is a special number in that it is prime. You guys remember what prime is? Prime is a number that you can't divide by anything except itself and 1. So you can divide 17 by 17 evenly, and you can divide 17 by 1. But other than that, there's no other number. Like 16 is divisible by 1, by 2, by 4, by 8, by 16. But the prime numbers, like I said, only itself and 1. Okay, so prime numbers have always been interesting for mathematicians. Now, I don't know if you know this, but you guys know what I'm talking about when I say cicada? Remember those, usually whether they are on July and August? and they make this unbelievable racket. Yeah, well, this is kind of interesting creature. They live for exactly 17 years to the day. What happens is they come out of their like a cocoon. They come out of there. They they're not alive very long. They reproduce. They fall. The babies fall down. The parents dig a little hole. They get in there. These kids stay in there for exactly 17 years. 17 years later, I'm not joking. They come out and the whole process starts over again. Now, why am I telling you about this? Why is that a big deal? Well, the 17-year cicada seems to have no natural defense. You know how God, think about every creature he creates, he gives some kind of defense mechanism, right? Like a lot of animals are really fast. The skunk is given in unique ways to keep people away from them or keep others away. Some animals have an incredible set of teeth. Some amazing claws. Some have built-in camouflage. But it's like nothing was given to the 17-year cicada. Well, so we thought. It turns out, as you know, 17 is a prime number. Okay, so I won't go through that again. This is just a little demo of prime numbers. All the numbers divisible by 2 are in red. Those are always even. So they're gone. Then all the ones that are divisible by 3 are shown in green. 4 in kind of a reddish, 5 in blue. And when you're all done, what's left? The numbers that are coming up in purple. And they're the primes. So there's not very many of them in the first 120 numbers. Okay, so anyway, that might help a little bit with what are primes. But here's the kicker. The prime life cycle of 17 years guarantees the longest predator-free lifespan for the cicada. Let me explain. The cicada predators have life cycles about 2, 5, 6, 3, okay? None of those numbers divide evenly into 17, right? So what that does is protects the cicada. So if the predators have a really big population year, for them to coincide with a big population year for the cicada is at its lowest possible probability because no number divides into 17. Well, except for 17, and there are no other creatures like that. So would you believe that means it'll be subject to heavy predation relatively infrequently, able to thrive and multiply over long periods of safety. Not only did God create math and each type of numbers, such as prime numbers, he actually uses prime numbers to protect some of his creatures. So I wanted to show you that. And then I wanted to stop and make a pit stop at 100 meters. And here, I didn't give one of God's creatures. 100 meters is about the height up there. Let's do that. Oh no, I guess I want to go further. I want to go to 140. Okay, 140 meters. I've got the Great Pyramid down there because the Great Pyramid was about 140 meters on the side. Okay, just about exactly. Now, let's see, I want to start with, well, hang on. I knew I'd get goofed up. Excuse me. Now let's just go back here. My apologies. Okay, now I'm just going to buzz up there again. There we go. Okay, so first, I'm sure you know about Noah and his ark. And this is the scripture reference from the NIV, which tells where God told Noah how they can make everything. Okay, so there's the dimensions. I just thought I'd share this with you. It's kind of interesting.
Can you refresh here, please?
Refresh. Yes, what I'll do, I goofed you up when I, let me think about this. Come here, and I'll reshare. I think that'll do it. How you doing? Do you see 140 on the screen?
I do now, yes. Thank you.
And the pyramid down on the bottom? All right, good. Sorry about that. It's because I switch around a little bit. Okay, so anyway, this is just talking about the dimensions of the ark, and I wanted to share this with you. There's, of course, a picture of Mount Ararat, and down below it, by the way, that's a, I don't know, there's a model of it, of the ark. It's in the library. It was a chance to look at. Pretty cool. Somebody donated. But anyway, this huge, humongous boat. When I was getting my master's degree years ago, I got it at a university in Marion Springs, Michigan. Anyway, they had this courtyard. This is at that university called Andrews University. Anyway, you see how in the background most of the buildings are 2 to 3 stories tall and go around this courtyard. Well, I had a teacher there who told me, and I thought this was so cool. He said, "Do you see that green grassy area there?" And I said, "Yes." And he said, "Do you see how high those buildings are around most of it?" And I said, "Yes." And he said, "Well, that's about where the ark, that's almost exactly the size of the ark." So in other words, the ark would fit on the green grass and would be about as tall as those buildings. Now here's the only reason I bring that up. That was so cool that he told me that, because for the first time gave me a better feel for how the size. You know, if you can compare it to something. A whale of a boat, huh? And Noah and his family built that thing. And yeah, and by the way, this is, if you do the mathematics, they know, they can pretty much figure out the displacement. The displacement was almost exactly the same as the Titanic. So in other words, the amount of water was so pretty big boat. And then, would you believe, there's this Christian by the name of John Hebers in Holland who built a replica of the ark. And I just thought I'd show you a few pictures of that. Now, I say a replica. He used, by the way, almost all hand tools to do it too. I don't know. You can see what it looks like. Doorway. And then he put some full-size model animals in just to show what that would look like. That's the builder. Can you imagine that project? I don't have any idea what it is. Can you imagine how long that would, I mean, it must have been most of his life. I don't know. Anyway, there's so much to discover, but mostly, so let's just go back to the beginning here. So mostly what I wanted to give you a different perspective on infinity, and in fact both infinities, the large and the small. Are there infinite sets? Sure. How about just 1, 2, 3, dot, dot, dot? Just keep adding one. There's no reason to ever have to stop. So, but when it's interesting how the math system kind of has to punt whenever you get to infinity. when you know, in math, when we get to that asymptote, when that line is getting closer and closer to that line, eventually you're going to want to divide by zero. And as soon as you divide by zero, poof, the whole thing falls apart. You can't divide by zero. And so it's just really interesting how with this marvelous system of math we have, when we come up against infinity, just like you and I, we're finite. And we can talk about it. Oh, by the way, there's a really cool, I didn't stop at it, but there's a really cool introductory slide. It's the words of one of the verses of Amazing Grace. And I don't remember which verse, but it goes like this. When we've been there 10,000 years, we've just as much time left as when we began. So in other words, after you've been in heaven for 10,000 years, you've got just as much time left in heaven as you did when you started. And that's what the hymn says, and that's another good expression of, now, how can I have just as much as infinity is? There's no end. Anyway, I thought this would replace the 2.5 lesson in the book. So do you want to have any discussion? So just so you know, my plan here tonight is I'll have to do some switching over from this to the other, and then I got to get Rhonda hooked up. And I thought we could discuss this a little bit, but then we will go into the review of the chapter for the rest of tonight. We'll do that in 2 parts, and we'll have a break. So, I don't know, by the way, with all these dimensions, did you notice that the Earth is right in the middle? Of course, that's because we can only discover out in here. Not in this way, the only place is where light is possible. And this fight is not just about water, ice, and places, and everything like that. This is the right place. Anyway, I just keep thinking of the words, let there be light in heaven. What power? Okay, Rhonda, did you have anything you wanted to ask about?
Not at this time, thank you.
Okay. So I need a little changeover time here. So excuse all the screen craziness that's going to happen here, Rhonda. Okay.
All right.
What did you decide to start researching on?
1978. And I was teaching in Michigan at a Lutheran school, and they asked me to give a presentation at a conference. And I had been running into things in even places like Reader's Digest and a few others. And if anybody would have told me I would be researching when it wasn't an assignment, I would have said they were really crazy. But that's what's happened. I can't put this down. And you're just seeing one little sliver. You're going to see it. You're going to see something totally different after our next chapter. Again, pretty different coming up in the chapter 8 too. Yes, sir.
It makes me wonder back to the Bible talking about Earth.
Yeah.
How is that possible?
I don't know. Maybe it could be that some of those names were provided by some of the early inhabitants at the creation. I don't know. I don't know that. But yeah. Well, telescopes were pretty new around the time of Galileo. We were talking 1600 something. Is when Galileo pretty much came up with the first one. So yeah, how did they know? Well, you got to understand some of those prominent ones, like our Earth can be seen on a clear night. I'm sure. So they didn't see it with a telescope. Why did they name it that? I don't know. And I don't know how that works. But that is remarkable. You're right. Okay. So let me close this up. Goodbye PowerPoint. And I thought I had the review up. Let me see. MFL review 2. MFL 2 review. There we go. By the way, I've had students in the past say that as a result of my presentation, they felt like a speck of dust.
We were talking about it and said, who am I? Nothing.
But just so you know, that's not what I was trying to tell you. Okay. I wanted, yeah, but you're right. That is something that seems to come out of that. Okay, now I got to reshare to get Rhonda back online here.
You said this off from the website? This all on that design.com?
Well, it gives brief descriptions on that website, designmath.com. It gives brief descriptions of each of the, I don't know, 6 of the 7 that I have. And there are links so that you can actually go look at some of them. I don't have everything up there, but like this one, if you guys want to see this slower and maybe a little more detail, I have a 2-part video that I did at our Wells Church in just south of Atlanta, Georgia, and I could share that with you. Okay, Rhonda, can you see the screen?
Yes, I can.
It says notebook advice.
Page numbers upper outside corner.
Very good. All right. So everybody, as we begin our review, I just want to remind you, you haven't handed a notebook in yet. And let me remind you, there are some things you want to have ready to go for next Wednesday, right? Next Wednesday is our target date for our first test. I am going to start the night off with some review. So this is not, tonight is not the only time. If you can email me, all that kind of stuff is just fine. But make sure you've done these things. Now that the chapter is done, you should be able to put your page numbers on if you haven't already. And have you made your table of contents? Now would probably be your time to begin to do that. Remember, I think I showed you a sample, so you can look at that. If you did extra credit, have you put the extra credit? Make sure you put where it is in the table of contents. So, you know what I mean? You might have placed some of your extra credit in each assignment. Some people like to put all their extra credit at the end. I don't care, just so you tell me where it is. And then, please don't forget to label the front of your notebook. So when I pick it up, I know whose it is. Okay. So just a reminder, it's been a while since we talked about the notebook. Does anybody have any notebook questions? It's been a while since we first talked about that. You want to see a model notebook, see Mike. Wow, is that a notebook? Okay. So, I don't know if I want to do this. I got all this screen switching stuff. I'm going to skip this. No, I guess we'll do it. Okay, so this is, we're going to give this a try. I might as well stick my neck out and let's try everything with this little distance thing we're doing today. So what I've got, I don't know if you've ever done an online poll, but let me open it up here. And Rhonda, I have to reshare as soon as this loads. Hang on. And do you have your phone handy, Rhonda?
I do.
The reason is because you can put, well, you can do it with your phone, or you can do it with your computer. Unfortunately, I didn't clear that. Okay, so we'll clear it out. Now I'm going to turn it on, unlock it, and okay, so here's how this works. What I've got, you can, this is for you to answer to me what you think needs, oh yeah, I got to share it with Rhonda. Sorry. Where is she? Oh, there she is. Coming, Rhonda.
All right.
No, this is what I want right here. Okay, you should see a web page shortly.
Math 116, Chapter 2 review.
That's the one. So here's the deal. This is a live poll where I'm asking for your input, and you can answer me either on your computer. You see the first heading up on the left there? It says you can answer at the website pollev.com/rbelo, or you can text your answer using your phone and text it to the number. The number you want to send it to is 37607. What do you send to me? The number behind your choice. Okay, or if you want to do a Twitter, you can do that too. Okay, any one of those work. So here's the idea. Which of these sections from our first chapter do you think need the most review? So give it a try. I know this, I kind of threw this at you. And Rhonda, it should work from where you are too, thanks to the good old internet. You probably don't want to use your computer because you don't want to lose, I don't know, whatever you think.
I got the phone might be, so I'm going to try it.
Okay. Anyway, when you guys vote, it appears up there the bars start activating. That's the idea behind it. And I know, actually, do we have reception here? We probably do. We can go by the window. The one I'm used, the room I'm usually in, is terrible. In the middle. Let's see how we do here. Hey, we have an answer there. I use it especially for my statistics class, and then we can get into statistics. We know if you need some help. We got another, oh, we have 3. So Rhonda, did you have any success?
Sending it now.
Okay, I'm not trying to rush you. I'm just
No,
curious.
that's fine.
Yeah, what it does is it readjusts, yeah. So like, if you're wondering why did the bar go backwards? Because another direction started that figure. And you'll notice the labeling on the bottom of the thing. It used to be the one was way off to the right, now we have it back off. And now, you see what I mean? So if more, we don't have very many people, but if we have more people, you see that sliding over even further. Okay, so I've got 2, 4, 5 votes. So I'm just, did your vote
I believe
get recorded?
I believe so. As I entered it, it seemed to, it was the 707, so it seemed to increase.
Okay. Yeah, now we have, you see, now we have 3, 4, 6. Okay, that's pretty good. Thank you for making it. Periodically, I'll do a little poll like this, usually at the end of the chapter. So now I'm going to make note here. Top priority goes to lesson 2.4. Second in command there is 2.1. And third is 2.2. So what we could do is just start in this order today, since most of you think after that, let's maybe take a look at some problems in 2.4. Okay, Rhonda, I'm going to have to do some switching again. Okay, are you back with the which material needs the most review?
Yes.
Good. Okay. I'm going to go then to, you can just ignore that. I'm going to go to lesson 2.4 and we're going to dig in there because that was the highest number of votes. So I don't know, you're going to have to tell me which part you want to do, but here's a you remember when we did these problems? What you always wanted to try to do first was to fill in the part. You know, I'm going to have to get the book. We're going to have to just get to do some live because otherwise I don't know. All right, so let me just pick a problem out of the book. 2.4. I'll pick out some evens. Okay. We did that even. I'll just do number 2 again. This is number 1, by the way, on page that you're looking at. This is number 1 on page 90. And in the book it said A has, you know, here, let me just erase the blue. Let's just kind of relive it here. Guys, notice my cursor a little bit slow. Yeah, we got all this going through and being recorded, so it's actually working pretty well. Okay, so now look at the problem. It says A has 15, B has 20. And yet, and then it says where they intersect has 5. By the way, that's supposed to be a 5 there. Can you tell me how many are in the union? Well, as we start putting numbers in the chart, where do we start? Which number should we put in there first?
5.
Yeah, the intersection. Get that in the middle. That's so important. Now, if A has 15, I can do this, correct? And if B has 20, I can do this. That's supposed to be a 5. Now can you tell me how many are in A union B? 15 plus 5. I'm sorry, yeah, 15 plus 15. Can all of you see that that's 30? Let's go to another one. Yes. Let me know when you're ready. No, I'm not too nuts about that technique, but that would work. Yeah. That's right. Add them up and subtract the overlap. That would be exactly correct.
Yeah, I'll just.
Yep. Thank you. That's good. Good that you brought that up. So Gumi just said, would it be all right to do it this way? Add the number in A to the number in B and then subtract the number in the intersection. And that works. So in other words, add the two up and then subtract the overlap. That's not the way I did it, but that would work just fine. Are you all set? Whoever asked me to wait? Okay. Let's jump ahead. How about if we do let's take a look at number 7. Okay. What does number 7 say? Survey of 100 students, number of students. Okay, so I got the answers up there, but let's start over. And whoever voted for this 2.4, in the meantime, think about what kinds of problems in 2.4 you want to do. I've only done a few. Okay, got to erase this too. All right, so number 7, we have 100 students, and we got this list. Which thing from the list on number 7 needs to be up there first? All 3 areas 25, right? Remember how you always want to fill in the part with maximum overlap? And isn't that usually the last one on the list? Sure enough, it is. You see that? 25. I'm not able to get my pen going. Here we go. 25. Now look for what? The double overlaps. Like right next to all courses, we have math and chemistry, 35. Right now, do you see where math and chemistry cross? In this thing? And that's supposed to total 35. So we need 10 here. Okay, next double. English and chemistry, 35. So we need 10 up here too. And then the last double, English and math, 30. So we need what, 5 here? Are you guys with me on that? Does that make sense? Now do your singles. And that's what comes next. Chemistry, 50. What do we currently have? 45. So we need 5. And the next one, math, 40. We currently have 40. So there's nothing out here. You could even do this if you want, or just leave it blank. And then English, 60. 35, 40. So we need 20. Okay. But what do we have? Well, we have one more job to do. Do you remember what it is? Yeah, and we got to compare it to the 100 we were told. Correct. So what do we have? 30, 35, 45, 70, 75. So therefore, we got 25 left, and they must be in the outer section. And then see if I answered them right. The first question on number 7 is, how many students were taking math but not English or chemistry? Yeah, it's that outer part, that's why that's 0. Part B, question there, how many were taking math and chemistry but not English? Math and chemistry but not English, so just the 10 and not the 25 part, right? And then part C, how many were taking English and chemistry but not math? Again, it's this, but it's a different 10, right? That one up on the top there. Okay, so we got a little start. What else would you like to go through on in that 2.4? Sure. Request for number 2, on lesson 2.4. So it's all done, but let's see what we got. So number 2, the number in A is 12, the number in B is 6. And when you put them together, you get 14. Well, you guys know that 12 plus 6 is not 14. It's 18. So how far are we off? You follow? If you add 12 to 6, you get 18. But we were told that when you do a union, it only comes out to a number of 14. So we're off by 4. That means that's the overlap. So now you can stick that in there. And once you've got the 4 in there, you can do the rest, right? So this it's a little bit tricky, but add them up and see if that makes sense. And if it's off, they just told you the overlap. Another request from lesson 2.4.
Number 15.
15, okay? Now, I should erase. You want me to do it over, or should I just?
No, you can.
Okay, let's just explain here. So what do we got here? On 15, we've got 100 customers at a restaurant. Nice name for a restaurant, Royal Hassel Restaurant. 100 customers total. I put that up in the corner. And we got all these different, onions, mustard, ketchup. So OMC, onions, mustard, ketchup. And way on the bottom, we got the ones that had onions, mustard, and ketchup. There are 5 of them. So you start with the 5 in the heart. Next, you want to do your doubles, so move up. 25 had onions and ketchup. Onions and ketchup. So that's this this ring here. And not a ring, but that football shape area. The total 25, therefore, you have to put a 20 here. Next double is what? 20 had mustard and ketchup. So we had 5, so we need the 15 here to make it total of 20. And the last double, 15 had onions and mustard. So we got to put a 10 in there. Then do your singles. 50 had ketchup. Currently, until we got to the outside, we had what? 25, we had 40. So we need 10 more to make 50. So 10 in the outside of the ketchup. 35 had mustard. 20, 30, 35. I'm getting hungry. Do you? Okay, cool. And then 40 had onions on their hamburgers. So currently we have what? 25, 35. So we need 5. And then you know what to do. The last step is add those all up. And evidently it comes out to 70. So I needed to put a 30 in the outer. Good, I'm glad you discovered something. Anybody else have a 2.4 request? You can come back, but I'm gonna move over to 2.1 now. 2.1, because we had a request there. We had what? Number of votes there. So let me just throw up some 2.1 slides, get us into, yeah. So first of all, this is where we learned there were different ways to describe a set. Do you remember? There were a listing where you simply list everything out. Then there was set builder notation, as you see here. And then the other one was with words. So there are 3 ways to describe sets. Okay, this is just a slide from there. Let me move on to something that's a question. How about 29? Number 29 on 2-1. It says, write the sets using the listing method. So 29, I see that's, what do you call that? Set builder notation. I've copied it up on the slide. All n such that n is a whole number less than 7.5. So what are all the whole numbers less than 7.5? Whole numbers start with 0, 0, 1, 2, 3, 4, 5, 6, 7. That's they call that the roster method or the listing method. That wasn't very hard. How about 44? Number 44. State whether the sets are equal or not. Okay, you're going to have to look this one up in the book. I'll write it on here. Okay, the first thing in number 44 was set A equals 2n plus 1 such that n is a counting number. Sorry, pen's not working real good. That reads counting number, sorry. So, what's the first counting number? 1. What happens when you plug in 1 for n? 2 times 1 is 2, plus 1 is 3. So do you see that the first number in set is 3? Then the second counting number is 2. 2 times 2 plus 1 is 5. Second counting number is 5. Do you see what I'm doing? Let me know if you don't. Anyway, let's just do one more. Let's take 3, the third counting number. 3 times 2 is 6, plus 1 is 7. Anyway, and that's going to keep going, dot, dot, dot. But now look at set B. Set B is described this way. 2n minus 1 such that n is a counting number. Those are quotation marks. Even though you can't read the word counting, I just copied it. So take the first counting number now, 1. Now multiply it by 2, and subtract 1, 1. So my first number in the set B is 1. So do I need to go any further? You're already mindful. There's no 1 in set A, so I don't have to go any further. Not equal. So to be equal, they've got to have the exact same contents. So I know those are a little bit hard to read, but just remember the slash stands for such that. So this is 2 times n plus 1 where, or such that n is a counting number. So then just take your first counting number, calculate it, take your second one, take your third one, get your pattern going, then go down and do set B. Yeah.
You're going to want us to write out any of the things, like show us the set and want us to...
I might, like, here, I'll give you one right now. I'd like you to translate this one into words. Okay?
I asked him on that. Do something like vowels.
Yeah, just 7 vowels. I suppose I should have one in the two. Maybe well, you would sometimes want. Is that how you guys learn this?
Yeah.
So, but yeah, there's a case where, oh, those I know what those are. Those are vowels. and then that could be a great way to do it verbally or with words. Or I might give you the list of the vowels. Write a listing.
Right, okay.
So yeah, I might do something like that, or I might have you, maybe one like that. Not a lot. I mean, I don't. There's one problem with I can't answer about it because we have enough time. But yeah, something like that I think would be a good question. Yes.
And so when you say, are you looking at them, set itself, or that is not the
Right.
is that what you're saying?
Oh, you're talking about subsets. Yeah. Okay, that's another topic. But here, what I would say to him is, one question is, I give this listing, and I say to him, supply a verbal description. And then he would answer the set of vowels. And then, backwards, what if I said, describe this with a listing? And then you could answer like this.
I was thinking of this.
Yeah, sounds like you were talking about subsets. Yeah, so when you get into subsets, what? I don't know if you want to do that. Let's see if there's any more questions on that. Let's look at what else we have. So that first lesson was more about getting different ways to describe sets. Okay, 53 was where we got into subsets, looks like, huh? So, remember we did that? How many subsets are there? If, well, I did it with
Oh,
one.
that's a good question. Actually, are you including when we do these, the improper?
Yeah, if you do 2D in power, that'll give you all the subsets including the improper. If you want only the, so the 2 to the n includes the improper subset. Yeah,
So I did start as a practice test,
yes.
and I think there is a question like that, but I believe it's the improper.
Yeah, so then you don't want the one that's identical. So on that, by the way, the 53 is not about catches. I don't know why I wrote that on there. But if you started with a set 1, 2, 3, 4, what are all the subsets? Well, first there's all the singles. Then there's what? Doubles. And I started with 1. So 1, 2, 1, 3, 1, 4. Then start with 2, 2, 3. By the way, why don't I do 2, 1? Because I already have 1, 2. Remember, does that thing different when you get into order? No. So 2, 3, 2, 4. Now the ones that start with 3, there is only 1, 3, 4. Now the triple. Triple, 1, 2, 3, 1, 2, 4, 1, 3, 4, 2, 3, 4. And then we would not list, if it was what you said, the proper ones, we would not list the 1, 2, 3, 4. But we would have to put the empty stuff. So what's n in this problem? When I speak of that formula, 2 to the n power, n is how many, yeah, exactly, how many elements there are. So what's 2 to the 4th power? 2 times 2 is 4. A third 2 would bring it up to 8. Another 2 would bring it up to 16. So all the subsets are 16. So let's just count. Do I have 16? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 7. And if, like in the test, they ask for only the proper subsets, you would only have 15. And 1, 2, 3, 4 would not be there. You guys all recognize what we mean by the improper subset? That's the identical copy.
I think part of my problem is that I'm thinking about one other lesson, doing a lesson, and I'm starting to confuse. I don't know if you have any suggestions for that.
First of all, that's one of the problems with dealing all these classes. At least we try to solve that a little bit by a certain definition. But I honestly, I'm not shocked. And time, what did I do? 2 or did I do 3? No, I did 3. Yeah.
And I noticed when I make my errors, it's so obvious to me once I made them, because I went through it too quickly. They were just things like you were saying, the test and take, you did for a long time, that's pretty long.
I have one suggestion for you, and that is, you've already started to do the practice test. That's what you're testing. When you notice something, like maybe on this question, write yourself a note.
Yeah, I don't know.
And then make a little list of those notes, and then go through those notes a few times.
It actually tells you if you have something wrong with each group.
Yeah, isn't that nice?
That's weird.
I know, that's another reason I like this book. Yeah, did you guys see that? Where they have the answers, they not only give you the answers, they tell you where to look. Get guidance, where that concept is taught. They give you the page, so it's a great study tool. Yeah, I'm glad you're taking advantage of that. But to keep them from being mixed up, I think I would write little notes to myself about the areas that have given me trouble, and then review those several times. I think that might help you get it.
It's also the language. You know, I have to speak the natural language. And usually it's that
You're right, that's all part of it. There is a whole different language. Do we want to do any more 2-1 questions? You know what I'm thinking? I'm sorry, Rhonda, I got away from you here. Have you been able to hear us at all?
Yeah.
Okay. I didn't know how good the mic would pick up. Because I couldn't see you, guess what? I forgot about you momentarily.
That's all right.
My deepest apologies.
No problem.
But
As
I
long as you're
remember you
answering
well.
questions, I'm fine.
Okay. I think we're going to break. It's about 7:10 here. So are you what? Are you 4:10? What time is
No,
it
I'm
over there?
5:10.
Oh, it is 2 hours.
Yep.
So are you guys on daylight saving?
Yeah. We're the same as
Okay, so we
Central.
go from Central, Mountain, Pacific. Okay, yeah, it is 2 hours. Sorry. Makes sense. Anyway, we're going to take about a 10-minute break.
All right, I'll be listening for you to come back.
All right. And then, yeah, those are our last segment. Thanks for good questions, you guys.
So there's a minus sign,
No.
there's A minus B, that's like the bouncer.
Correct.
But when there's no numbers to bounce, A minus
And you just don't have anything to do.
okay,
So,
that's fine.
yeah, I know that seems like, wait a minute, am I not supposed to do something? Because when you subtract numbers in arithmetic, you always have to what? Go into negatives or something? Yeah, you can't bounce somebody who didn't show up to the party. So that's why I use the term bouncer. So what is the bouncer? How does the bouncer feel about that? He's probably happy. He's got a little less messy activities to do. So do you have an example in
Yeah,
mind?
I was looking at 5 on the practice test.
Okay, let me go there.
Yeah. And it's number 5.
Thanks. Even though we're on break, I got a question on the practice test here.
Are you okay with that, or do you want to?
Yeah, I can.
That's fine. No, I'm very happy to do those. Okay, yeah. So you were supposed, did you get the direction? So this is number 5 on the practice test. And part D, she's asking about where it says A minus B equals all X such that X what? Is or is not an element of A and is or is not an element of B complement. Well, okay. What maybe makes that one tough is they used and, which means you got to do an overlap. Okay. So obviously, I'm going to start with A, so we know that's got to be is an element. But then we're going to take away B. Isn't that the same as overlapping with everything outside of B? I'm sorry. Yeah. And the B is already a complement, so I actually have to say it is an element in the outside of B. You follow? If they,
Are you going to use that why that is not why it's in that?
well, because I use B.
Oh, I see it.
This might have made more sense if they had done it this way. But they snuck in a B complement. So if you had said not an element of B complement, that would have put it right back into B. And we don't want to overlap everything in B. So yeah, this is what, an alternate view of part B. That one was a little tricky by them putting that in there. Yeah. See, is there any more down there?
So this one might be like super easy and I'm overthinking it, but it must be in the text, right? So that's why maybe it was somewhere else, but it's A intersects with C and there's no parentheses. A intersects with C, intersects with C.
Okay. And what are the directions?
Oh, I don't even know where I got it. I just wrote this down. I wanted you to solve it.
Okay.
Oh, yeah.
Is that from the test?
Well, here's what I meant by directions. If it was a Venn diagram question,
Oh,
then I would do it one way. If they told you what's in each set, then I would do it.
okay, I believe it's a vent.
So, okay, then,
Yes, it is.
so right here is the A, let's say this is A and this is B.
So you just start with that right away.
So, yeah, and so far, this first part, the answer is right here, right?
Oh, is it this one?
So for this first part, that's shading the answer. Now, I have to take that football shape and find out where that overlaps to. Well, I didn't want to do it. Here's that football shape that I have in there overlaps to. You see that? That's it. So that's your final.
So you just broke it down like doing it slowly.
I did it. You can't do it all. Well, maybe you can. I personally prefer doing one thing at a time. And by the way, there were no
Maybe
parentheses.
it's because there were parentheses that I was like, wait,
Yeah.
this is just, yeah.
So what do you do in math when there's no parentheses? Like if you have
Word to word, I guess.
left to right. That's kind of what I would. By the way, if you have no parentheses, I could have gotten C intersect C first. And then intersect it that way. You really don't have to go left to right. It's just a habit I have. So with no parentheses, there's really nothing holding you back from doing whatever you want to do first. You just gotta be careful. What did you miss? Make sure you pick it up.
And then, if you could you just
Yeah.
explain 16 on the test?
16 on the test. Yes. 16 on the test. And if you want, I'll do it over. Okay. So it says, let the number of elements in set A be 25 and the number in B be 35. Find the number in the union of the two if, in part A, they overlap in nothing. That's what that A intersect B equals, that's the empty set. So what they're telling you in part A is, what if they miss each other? And that's what I've drawn.
Oh, you make it feel so.
Well, as long as you,
What suture are you gonna use? I just have to throw it back at you just so I don't just know.
I don't know, you better tell me, because I need somebody to make it easy for me. By the way, have you heard about another? I haven't given this presentation, but the next chapter, I'm gonna give a presentation on how to study, the use of scholarship,
Oh,
to
yeah,
possibly use this system.
absolutely.
It's not flexible and it's stronger than steel. Anyway,
No,
it just made me think of
the
that one.
coolest thing I almost had was, there was MJF Zoo, long as 22, was the orangutan, and she had colitis, and she was very ill, but we never got the chance to get over there. I just wanted dying to see the inside of an orangutan, and remove her gallbladder left and got it like, that was like the coolest thing. I was having so much fun.
So you didn't get to,
No, she passed away actually several months ago, but I just wanted to see the inside of an orangutan and how different you might treat that situation.
I was wondering.
any idea how old they were?
I almost think she might have been in her 30s,
Oh, okay.
but I could be wrong. I might be mixing it with some other story. I was just.
It
going to
should
be very.
look, I bet it looks an awful lot like,
I'm
a human.
thinking,
but
you know,
that would be my guess.
in the books, you know, you can look at every anatomy, physiology.
Every animal you
And
want.
then you know, get it, do little surgeries of, wow, it's not quite the textbook. But she was sick for about a year, and they called trauma surgery for years.
So you get the difference in part B?
Totally, like I said.
Now they're
it was
saying if they
plain-
do overlap in 5, now what? Is the, of course, then you have to re-figure this out. So that total's 25 and this total's 35. Oh, now when you add them up, I guess 55. Yeah.
No, it's completely different.
You know, that's.
Good.
And I guess with part A, I have put all these things in my head that,
Another one of these tools to remember.
well, and they're disconnected.
Yeah, but what this is saying is they overlap in nothing. Kind of a backwards way of saying they will. Put it in, what, World Series terms?
We always have intentions for follow baseball, and then it's kind of go off. Like a month into it.
I know Luke is huge for
He is. He is. I know, and when he was going out with his gal he married, of course, they're from where they are now. And they went to the Brewers versus Twins game in Twins Stadium. And so, of course, Luke showed up in all his Brewers. So
Oh, yeah.
he's not gonna change that.
He had a difficult time in class, I remember, during games.
Oh, I suppose.
He just had this itch
Yeah,
to find out what's with the score and what's going on.
I know, and he had another connection too, because he lived, almost like 20 miles from the stadium, so sometimes they would watch the game. Yeah. You're right. Not quite ready yet, Rhonda, hang in there.
No problem.
We've got,
She's got sunshine, she's fine.
we've got one more to go.
Oh,
I
that's
know.
so horrible.
And all of you should really say hi to her.
Hi, Rhonda.
Hi, Rhonda.
Hi, everybody.
I was trying to have her be on the conference, but doesn't want to have my laptop on. I don't know. It just doesn't want all of it. Guess we're all here, huh? So, ready to continue now. Do you want to do any more 2-1 stuff? Let's go to 2-2 then, because that was the third most requested. And by the way, if you want to intersperse questions on the practice, I'm fine. By the way, I think the practice is awesomely valuable. If you haven't done it yet, Well, you want to get a real taste of what the test is going to be like? No, I'm not. Obviously, it's not a copy of that. For the same kinds of questions. So that at least when you come in and look at my test, you're not going to go, oh my gosh, what is this? I hope.
You still might.
Yeah,
Because after a week of work.
yeah, we still might, but at least you won't. I've had professors where I was just totally stunned when I saw the exam. I studied for all the wrong stuff. I know that one of those. That should not happen. It should be a practice session. So, and I like Michelle said, they give you help for finding out maybe what went wrong. So it's really good for study. So should we go back to 2-1? No, I'm sorry, 2-2. Lesson 2-2 questions. Rhonda, you haven't asked any yet.
I figure I spent all my time in the last class asking all the questions, so I thought it'd be quiet this time.
Well, no, you don't have to. You're in the class, dear. Ask questions if you like. So here's the kind of thing we did in lesson 2-2. Given sets, we were learning how to use union and intersection and how to use parentheses. So like here, we were given those three sets, A, B, and C. Can you find A union, parentheses, B union, C? Now with the parentheses, do that first. So what's B union C? Well, it's these two things pasted together. So 1, 3, 4, 6, 7, right? And then, now that I've got that, unite that with A. What happens when you take these two and paste them together? 1, 2, 3, 4, 5, 6, 7, right? So this was just, these are basics on how do you do union, how do you do intersection. Here's one, number 13. Oh yeah, by the way, I gotta just tell you, probably, I think I gave you this question, I shouldn't have. Here's why. I'm gonna tell you that I will stay away from sets within sets. You see how within the set B, there's yet another set? I'm not gonna do that. So anyway, my apologies. I shouldn't have, I won't do that on the test. Okay. Number 17A on 2.2. A union B complement. And all the set contents are shown up at the top there. So what's A union B? A, B, C, D, E, F. Just look at them. You gotta look at the book in order to get this. It's on page 70.
I'm sorry, can I back?
Sure.
You said the first one, the one that was A, union, B, C?
Yeah.
That was the final answer is 1, 2, 3, 4, 5, 6, 7?
I thought so. Did I goof it up?
No, I just worked it myself because I was still ready to go.
Oh, I got you. Yeah, 1, 2, 3, 4, 5, 6, 7 down there on the bottom right. Yep, you bet. That is correct. So I'm just slipping back to this one we were just looking at, 17A. So if you look at page 70, look at 17 and look up above in the paragraph. It tells you what the sets are. What happens if you take A union B? So if you weld those two together, can you see that you would get A, B, C, D, E, F? You don't want to do any better enough? Okay. Well, then so that's where I got A, B, C, D, E, F. Now take a couple minutes Well, what's the complement of A, B, C, D, F? The problem is that's the universal set, A, B, C, D, E, F. So what happens when you take the complement of the universal set? There's nothing. So that's why I put, by the way, remember, you can either answer that these letters B is the same for the empty set, or you can just put two braces with nothing. Or you can just write EMPT space XTT. Only to get the concept. Let's move on. I don't know what. Any requests? I'm just flailing away here because I'm not getting any questions. Should we take a look at 24 then? So this is at the very bottom of page 70. We're supposed to do C union B, parentheses, complement, and intersect that with A. So what do we have to do first? C union B, right? Okay. What's C union B? A, B, D, F? C, D, F. So A, B, D, E, F? Oh, I was doing A. Right. C, D, C, D. A, B, isn't there an E in
Oh, is it?
there's an E in set B.
Oh, okay, I'm sorry.
So I missed it, didn't I? Oh, yeah, I got it on the right. I see. I got C in. Now I see what I did. I wrote it out the wrong way. So what happens when you join those together? A, B, C, E, F. Okay? Don't forget, you still have to take a complement of that. What's the complement of A, B, D, E, F? You have to compare it to the universal set when you're going to do the complement. And there's only one thing missing, isn't there, from the universal set, C. So the left side comes out to C. Now intersect that with A, C, E. What's in common? It's C.
You go back to B.
Yeah. If I copied it right below C, I've got set C, which is ABDF. So what I did here, Mike, is I just put C, here's set C, and here's B.
So you just don't, you don't do repeat.
Yes, that's correct. You don't do repeats. Yes. Correct. So now that I got them listed out, what happens if I join these two together? Well, I got A, B, D, E, and F. Does that make sense? Because we don't repeat the D's, we don't repeat the D's. You get that? Sure.
Why did you bring that around? Why did you make that a? You figured out C union B in the first place.
C union B, yes. And when I unite it, I'm going to put it down here. And then that still had to have the complement, so I left the complement somewhere. And then in the next step, I had to take the complement of this.
You don't have to really do that first step there because
No, you could have done this C union B probably in your head. Yeah. I went full detail here.
I see. Okay.
Yeah, I didn't see that at first either.
That's what
And I even wrote it. So, yeah, and then the right side really wasn't much to do until the end. Yeah. So you want to look at, somebody want to pick another problem on Q2? I'd rather do the ones you want me to do. Well, let's hop ahead then. I'm going to take, let's take a look at number 37. Yeah, well, 37 is just this one. Okay, so in this, look at the directions here. It says in problems 29 to 38, the universal set is some universal set of which A is a subset. So A is part of the universal set. In each case, find the indicated set in terms of A, the universal set, or the empty set alone. So 37 says, take the complement of A complement. So you can picture it. Maybe this picture will help. So A is a subset of the universal set. So where's A complement? And where's the complement of that? And what's the simplest way to name that? It's A. That's what I've answered. How about 35? What's the intersection of A with A complement? What's that? Union would be, but not in the. So what they're saying is take the outside, take the inside. Where do those two overlap? Does the outside overlap with the inside? No. So they overlap in nowhere. So I would answer that one with the, the empty set. What about 36? So now, this is, I think this is the one you asked me about. What happens if you unite those two? What do we have? The universal set. Yeah, maybe that must have been the number you're thinking of.
Yeah, because I'm thinking that when you say overlap, A over
Oh, A, you're right. A and the universal set do intersect. But that's not what we were intersecting in 35. Yeah. I see. You're right. That can be confused. Any subset overlaps with the universal set. That's true. Yeah. 33? Yeah, let's look at 33. A intersects the universal set. Again, the picture might be helpful. Actually, we just did it. Where does the content of A overlap the universal set? What are we doing? 33. Yeah, overlap. Isn't it A? Okay. Because the universal set is this whole thing, right? Oh. Where's A? Right here. Where do they overlap? If you can't, sometimes if you can't see it, go ahead and strike it in. Now here's the universal set. Here's A. Where do they overlap? Now it's really kind of sticky between that and so if you have trouble visualizing, just I would encourage you to go ahead and use colors or striping. You want to do any others in this section? Yep, number 8 on the practice test we're going to look at next. Sorry, Rhonda, I was away from the mic again. Number 8 on the practice test. So while I'm scrolling, Rhonda, how have your meetings gone so far?
We just got here today, so
Oh, okay.
haven't had meetings yet.
Got it. Okay, so here's number 8. I've got it up. I've actually got the question up here this time. Draw a pair of Venn diagrams to show that A remove B comes out the same as A intersect B complement. So that means you got to make 2 Venn diagrams. Make one Venn diagram for the left side, make a different one for the right side. So here's my answer. A take away B. A remove B. So in my head, I first had A, the whole A circle filled in. And then we erased the B. So you see that would leave 3/4 moon like that. But now this one has to be done totally differently. Here I want A intersect B complement. So intersect is what? Is that an overlap or is it going together? Overlap. So I'm going to shade A one way. So I shaded A this way. And then do B complement the other way. Everything outside of B. Everything outside of B. And because it's an overlap, where's the answer? Where's the cross-hatching? With the cross-hatching here, agree with what we had over there. They're both 3/4 moons in the same place, okay? Right? This answer is the same as this. Why is this the answer? Because it was a intersection, crosshatch. So we've shown, yeah, they really are equal. They really did come up. By the way, the biggest error I see if I'm given a question like that on the test is I usually have students, if there's an error, what students will do is just make 2 of these. I can't get full credit for that because these 2 sides are totally different. You know, yes, they're going to be equal. They've already told you they're equal, but don't just show them the same diagram. So on each one, just execute what it says. So here I just took out the B part of A. Here I had to do an overlap. But you hopefully can see they did come out the same. So please don't just give me 2 identical. If you did that, I'd give you credit for half of it. But you want to get full credit. So. Does that make any sense? Yeah.
Can you do problem 10 on the practice test?
You bet. Problem 10 I have a request for on the practice test. Wow, my computer just asked me a question. They're becoming more lifelike. All right, number 10. So I've got the question here. Find the sets of, you want to do both parts, Rhonda? Yeah. Anyway, I got them both up here, A and B. So find the numbered sets in the region. Okay. So the first part, A, is A union B intersect C complement, which I also wrote down. Over here on the right side. Okay. So what's A union B? Now this time, Mike, I didn't do it the long way. So when I did this one, when I did the A union B, I did that in my head. So what's A union B? Take the 2 circles over here on the diagram and take them all together. So what do we have? 1, 4, 5, 7, 2, 6. All right. Now intersect that with C complement. What's C complement looking in the picture? Everything outside of circle C. So what is that? 1, 5, 2, 8. Don't forget about this one. That's outside C too. Okay, now final step, intersect them. What's in common between these two sets? 1, 5, and 2. And so part A is now done. Does anybody want to follow up on that part? All right. Part B, A complement, union, the parentheses, B complement intersect C. So let's do the parentheses first. What's B complement? Everything outside of circle 1, 4, 3, 8. Okay, intersect that with C. What's in set C? 3, 4, 6, 7. What's in common between those two? 3 and 4. Okay, and now what's in A complement? What's outside of A? 2, 6, 3, 8. And lastly, join these two together by pasting them together, a union. 2, 3, 4, 6, 8. I don't know. Hopefully that helped. Does that make sense?
Yeah.
Okay. By the way, Rhonda, how did you get your invitation today?
I don't remember. Through my email.
Okay, I invited you in a slightly different way. I've been doing research and I was just wondering. So you did. So the email continues to work for you.
Yes.
Good. Okay, glad and it wasn't a struggle.
Nope, not today.
I'm glad. Good. Okay, 11 on the practice test. Here I did number 11. So the question is, in number 11, when you use the numbered regions in the diagram, which I made there, how can you show your work? So here I did my work. So A intersect B. Where do A and B overlap? 5, 7. Union C. What's in C? 3, 4, 6, 7. Join them together. 3, 4, 5, 6, 7. So you treat the regions as if they're step elements. Does that make sense? And then, of course, they better come out to be equal on both sides. Yeah.
Will there ever be a point where it evens them out on the test? Or
No, I mean, if I ask, how is this one worded? I don't have it here.
is this number 3 through the diagram that's all the time to verify that
Okay, to verify, meaning
it's going
show me it's true. If I'm going to have you verify it and then it doesn't verify, that would be a lie. I'm not going to do that. I mean, if I say to you, check if these two expressions are equal, well, that's a different matter. Then if you actually do it, you don't, you just say no. So the wording of the problem, if I say verify something, I mean show me it's true. Yeah, and that's what the book says there. Yeah, she was, I don't know if you caught that, Rhonda, but she was just saying the directions for number 11 on the practice test said verify. I mean, show me this equality really is equal. So, and she said, will it ever happen that they're not equal? Well, not with that wording. I mean, if I say verify it, I mean, show me it's true. I'm not going to lie to you. And then when you say, yep, see, it's true. And then I go, ha, 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 it's false. No, I'm not going to do that.
Okay.
But on the other hand, if I asked a question and said, are these two expressions equal? Well, then you could actually test out the two sides and see if they come out the same. I don't think the book ever did that, so I probably won't either, but I'll kind of stay with this style, I think, pretty much. You guys are really asking good questions. It makes you very enjoyable to teach. Everybody sits there and just stares at you. That's when you know it's isn't going to work real well. But you guys aren't that way.
How many questions did you say again?
I said there were too many in the book. How many were there in the book? Well, first of all, we dropped 3, right?
There's 20 in the book. Oh, no, sorry.
25, but then we took 3 away. So that was 22. That's still way too many. I would say 12, maybe 14. I don't know. This is just a little too time consuming for what we got for one. Even though we have a little more time options, I'm trying to be true the same length of test that I did in my class here, where we had 50 minutes. So that doesn't mean everybody's going to finish in 50. Well, probably some will be done early, and probably some will need additional time. That's fine. So I have this weird goal that after the test, I'd like to teach 1 or 2 lessons. If you need, but I don't want people to feel pressure. So I'm not, I think what I wound up doing last time was because some people needed a good extra hour to finish, and I didn't want them to, have it really going, stuff like that, or that I didn't want them to feel pressure. And I'll try to keep similar this time.
It doesn't work for the Sunday.
Okay, that's a good question. Because
Maybe we start a new lesson on Sunday.
I'd rather not do that. So what do you guys think? Do we need more review?
Just over reviewing it in the past and giving it practice.
Yeah. If we had done the test today, then my way of using Sunday little things, what I've done in the past is I corrected the test, give that in, and then I scan them in color and send them back to you by email. And then we actually go through them online. But of course, we're not in that situation. I don't know. I have to think about how we're going to do that. It's really more up to you. I don't want to cut off question. I had planned it for additional discussion with you guys, but if you don't think you need it, I'm not going to force it on you. It would probably work if we could skip it. But then I'd really like to teach 1 or 2 lessons after the test. I don't like this idea of starting a new chapter and having finished the road. You know what I mean? That crossover, you guys have enough jamming and things together already.
So maybe, I don't know, next week, we could start with the test early.
Because,
Review first thing at that time.
yeah, again,
one lesson.
and then, yeah, see, here's the other. To not have pressure on people who want to complete the test, you're still going to have some people waiting for others. So it would be cool if we could reverse it, but then we're crossing over again. I don't want to teach the 2 lessons. But you're right. Only reason I put that there is I'm just trying to be, you guys have had all this planned that too, and I'm just trying to give you enough time to do it.
I think if we use this week, the remainder of this week for next week, work on practice tests again and review all our notes, then next week we try to immediately review before the test.
No, but we could do like 10 minutes. Are there any remaining questions? But yeah, not a whole question. I'd like to do a little, like somebody might have said, boy, there's one I'm really good. And I'd love to answer that. But you're right, it could be true. So I'll tell you what then, What do you think? Do you think we need Sundays? You know, here's the other thing. You guys can contact me anytime you want to. So if Sunday you're sitting there going, well, if you have some time, hey, let me know. I'll do a hangout just with you. And so it doesn't mean it can't with you. So let me remind you of that. You can do that. And then I like Mike's concept. Just do a brief couple questions at the beginning. We'll get into the text early next Wednesday. I'll try to, we'll see how it goes. We'll try to navigate to a point where we can still teach at least one lesson on Wednesday. And then I'm okay with skipping Sunday.
You know, it's crazy.
What's that?
I got this book on Amazon, you know,
Yeah.
these nationwide, whatever, and they have the same questions that says they exclude X out.
Mine is too.
You know what?
Yeah,
That's gotta be from my class.
Mine
That's what I'm
mine is
thinking.
too.
That's my next.
Those have to be from my class. Because nobody, I don't think anybody else. The same question.
Yep.
That's gotta, so that had to be some student that took the class from me.
Yep.
And they, what, you can sell books to Amazon?
Yeah.
You can sell your used books? That must be what they did. Huh, that is wild.
Yeah,
I would have
that's-
never guessed that. So what do you think? We need more tonight?
As we do
Yeah.
the table of contents,
Yes.
if in my note taking, I have some on the same page as just like notes from lessons. So it's
That's fine.
okay. I
Oh,
can put
sure.
that same page on
That's perfectly fine.
those. You don't need them, I guess.
Separated?
No.
No. The fact that you, yeah, so what's saying is she listed terms for a page and she had notes for that same page. That's perfectly, that's perfect. Don't change the thing. Yeah, anybody else have a notebook question or issue? This is your first time around on that. If not,
You don't need the
either, some people put that in as like, what do you call it, a preface, but it's not, you don't have to have it in the career advisors. If you leave it in the college book, that's fine. Okay, guys, thank you. I guess we're gonna hang it up. Have a good week. So, Sunday,
Oh, I was going to ask your preferred method of contact, or if I texted you and said, I sent you an email with some questions I asked,
yeah, that's cool.
so I don't.
You can do either. The only thing I ask is if you text me, tell me who you are.
Oh,
Because I don't know all your phone numbers. So this happens in class here. I get this text message. What was the assignment? I don't even know what class they're in, you know?
oh,
Who are you? So I write back. Really great text back. Could you tell me who you are? Oh, this is Johnny. Well, which Johnny? I've got five. So it's just, it's kind of weird. You know how usually you text your friends, and then when they see the phone number, they go, "Oh, that's Michelle. I know who that is." But I don't have your phone numbers memorized, so just let me know who you are. Yeah, I like that. You could say, "I sent you an email. Could you please answer the 2 questions that are in there?" or something. Yeah, that's great. By the way, if I get an email question, well, sometimes what I'll do is I will write out an answer, and I will. In addition to what you see there, I'll have like a paragraph explaining why I did what I did.
that works.
And if that usually works for people. So, like here, I don't have any explanation, but I would include that in my. Okay, thanks, guys.
Thank you.
So Rhonda, I don't know if you heard that, but we're ready to hang it up.
Okay. What's, the part I wasn't clear on was what's happening Sunday.
I think we're calling that off.
Okay,
But if you want to ask me a question, we could even do just like a 2 or 3 person hangout if you want. But what they're saying is we had a pretty good session today, and I think they're saying they don't think they even need to do much in the line of review next Wednesday.
Okay.
But what I'll do is on test day, I'm still going to take 1, 2, 3 questions if there are any, but we'll get into the test fairly quickly on Wednesday. And then I'm going to try to teach at least one lesson after everybody's done with the test.
Sounds like a plan.
Hey, I've never seen dedication like somebody who went that many hundreds of miles away from class and still attended. That's pretty awesome.
Well, I want to make sure I pass, so I need all the help I can
Yeah.
get.
You do, because you're at like D minus right now. No, no, I'm sorry, bad joke. Should never tell a joke like that.
No, that's fine. I understood it was a joke.
Okay, good.
All right. Well, thank you very much. I appreciate again a lot for you taking the extra effort to bring me into the class like that. Thank you very much.
Actually, worked out very smoothly tonight. Thank you.
It did. All right. Have a good evening. All right.
You too.
Bye.
Wanda, have a good work day tomorrow.
All right. Thanks. Will do.
Okay, bye.
Bye.
Oh, yeah. I got, by the way, I got a student in my undergraduate class who needs his work. So I said I might get this one back.
Oh, yeah.
Cool.
I got it.
Well, good.
Thanks for reminding me.
Yeah, did it help at all?
Yeah.
Okay.
Perfect.
So I was trying to learn about my students. Did you play football at Milwaukee Lutheran and Concordia?
Yeah.
Is that right? Oh, no, not Milwaukee Lutheran, but yeah, it was Milwaukee Lutheran.
Yeah.
Okay. Cool.
So
So how long ago was that you played
college football? My last year was 2012, so
Okay.
3 years now. But
what position?
I was a linebacker, and I actually played them off on the line. In my sophomore year, because we were so thin on the offensive line. So my high school coach knew me, Lonnie Priest, from back in the day. He doesn't run through this machine. He likes playing football position, and kind of stuck me in there. It was kind of really cool experience. He played both sides of the ball in college.
Yeah, that's pretty unusual.
Yeah.
So you played WLC.
Yeah, we
was
did.
It, went forward.
Well, we're in the same conference, Northern Athletics Conference. So
Yeah.
I actually have my name against these guys.
You do?
It's fun. And I tore my ACL my last year, or else when I transferred up here, I was thinking about playing here too. And when I came up here, I guess they won the conference like a couple years in a row now or something like that.
Yeah, they had one anyway. Yeah, they had a good year.
Yeah, that was pretty cool to see. So,
Oh, cool.
but
So you almost. Yeah.
I'm kind of sad. I was on another one, but
Okay.
yeah, he did won our conference 2 years when I was there.
So he is all healed up now.
Yeah, it feels good. I'll do some little stuff, but it's the process.
Yep.
We did better. I was gonna ask, when we're doing hangouts,
Yeah.
I didn't see anywhere to type, to respond to you. I was like, to just text you or text you.
The backup way is to use a text message.
Yeah.
That's only about 30 seconds behind.
Okay.
But that's not bad. But if you're supposed to get an invitation where you can be a full participant, and then your picture actually would appear down on the bottom, and then you could talk whenever you want.
Okay.
Like Rhonda was talking to you. That would be the ideal.
Yeah, I just use invitations with email person.
Yeah, now there were 2 links in the email.
Oh, really? Okay.
The top one is for live.
Okay.
The bottom one is just video. But some people have had technical problems with the
I
live.
think I was just looking at your Google Plus account or whatever.
Yeah, that's another way.
So
There's an event there,
yeah, that's what I was doing.
and that opens up the video.
Which, I mean, it was fine, it worked.
Yeah, it's not bad. It would be even better if you could be able to live. Because then we could really easily,
Okay, so.
keep follow through. Try it. If it doesn't work, you can always, use texting. There is a chat window that can be opened on the right.
Yeah,
Maybe you guys didn't have that open.
I don't know.
Anyway,
I
That might have been my fault,
no,
but
no worries.
you can always send a text. And then I leave my phone, so I can hear when the text comes, and then I right away look out.
Yeah, you're kind of more into it though. All this software and whatever, than a lot of people are. That's
Well, I'm trying to keep up with it. Is this
I
one?
never saw the poll, the interactive poll thing machine you did.
Oh, yeah, isn't that kind of cool?
That is,
Yeah, by the way, that's free.
yeah, I broke down the website. It was poll everywhere.
Everywhere.com,
That's
yeah.
pretty cool. I do like that.
Yeah, and when you talk to a big, the only limit I have is 3 pounds. You can only do 35 people.
Oh, really?
Well, most of my classes are 30 or less, so it works.
Yeah.
So if you want to do, like if we are at a big school and got a big lecture,
Yeah, like,
then you got to pay. Then you got to pay. If
yeah.
you go over 35, I don't know. Anyway.
That's cool too. I like that.
Oh, good. I'm glad to hear that.
But, yeah, as well as the divine math, which is, I got to check that website out as well. So.
Cool.
All right, have yourself a good week.
Thanks. You too, Andrew.